Hi everyone, so in this video we're going to be looking at the rate of a reaction. Now rate basically means speed of a reaction, and speed is going to be looking at how fast the reaction is taking place. So a reaction can be very slow, for example rusting, which can take place over years. Or you can have very fast reactions, for example explosions. And you can have moderately fast reaction, for example, acid-base reactions. Now, there's different ways that we can measure the rate of a reaction. We can look at how much product is formed in a given amount of time, or how much reactant is being used up in a given amount of time, or how much, how fast a color is changing, or how fast any kind of change is happening in that reaction. So color fading or color appearing. Now if we look at this example where you have calcium carbonate reacting with hydrochloric acid, this reaction produces carbon dioxide gas. And because it's a gas, so we can collect this gas, so we can see how much gas is being produced in regular intervals of time. So this is an example of the equipment setup where you have in the conical flask, you have calcium carbonate and hydrochloric acid, and you have the gas carbon dioxide which is going to be produced and collected in the gas syringe. So with time, we're going to have gas which is going to be produced. This is my timer, which is going to be used to record the time intervals. So with time, you will have gas that is going to be produced. So as the reaction is proceeding, we'll have more and more gas which is going to be produced until all the reagents are used up. So there is no calcium carbonate or there is no hydrochloric acid. One of the reactants is used up, so you won't have any further carbon dioxide that is going to be produced. So here, if we look at the graph, so the reaction here keeps on going all this time. Reaction continues, but as soon as we reach a certain amount of time, it stays constant. So we know that here the reaction has stopped. So the reaction has reached completion because one of the reagents has been used up. Now, if you look at this first part of the graph, you see that the volume keeps on increasing, but it increases by a decreasing amount. What does that mean? It means that initially we have a lot of carbon dioxide which is being produced, and here carbon dioxide is still being produced, but there's less and less of it which is being produced with time. So the total volume increases, but the rate at which, the speed at which the carbon dioxide is being produced is decreasing. So as the reaction proceeds, the rate decreases, the speed decreases, and here the reaction has reached completion. So here rate is 0 at this point here. Now, another way that we could use to measure the rate, to investigate the rate of reaction, is by looking at the reactants. Because we have a gas that is going to be liberated, so it goes away, if we allow it to escape, we'll have a decrease in mass of the system because the gas is escaping. So we can measure the total mass of the reaction mixture with time. So here we have a mass balance that is used to record the mass of the reaction mixture. So you have the mass of the conical flask, calcium carbonate, and HCl. Calcium chloride produced will stay here, water produced will stay here, and all the carbon dioxide produced is going to escape. So we have the mass that is going to be recorded with time. So because carbon dioxide is escaping, so the mass is going to decrease with time. So mass of reaction mixture is going to decrease with time. So initially we'll have a lot, and then as the reaction is proceeding, the mass is going to decrease. At one point when all the reagents have been used up, so which means that this point over here reaction is over. So as you see here, mass is decreasing with time. So we have an idea of the rate. So the rate of the reaction is decreasing. Now, how can we study the rate? How can we calculate the rate? Here in this experiment, rate is obtained by decrease in mass over time. In the other experiment here, rate is going to be obtained by the increase in volume with time. So these are two experimental ways that we can find the rate of a reaction. So now let's see this reaction. You have 60 centimeter cube of gas that was produced. Let's say this is 60 and this is 5 seconds. So let's say you have, let's say this is 5 minutes. But the time here is in seconds. So let's say you have 60 centimeter cube of gas that was produced in 5 minutes. So then the rate is going to be, rate is given by centimeter cube per second. So you have to change the minutes to seconds. So when you do the calculation, it's going to be 0.2 centimeter cube per second. That will be the rate. Now, graphically, how we can get the rate? The rate at any point on a graph can be obtained by the gradient at this point. So if I draw a line here and I can find the gradient at each of these points, the gradient at these points will give me the rate. So from a graph, rate can be found at any point from the gradient at that point. So this is for the first part of this unit.